Hello, good afternoon, class. Today I'm coming to you by internet. We're going to cover Chapter 6, more on chemical compounds. It's the same as usual. We're using the textbook Introduction to Chemistry by Mark Bishop. These resources are available online, so please follow along in whatever format is most convenient. So first, you're familiar with the chapter map. I'm not going to go through it. I want to proceed directly to the action. Okay, so monotonic ions. In chemistry, we have to communicate what we're dealing with. We know that chemistry is the study of structure and behavior of matter. But because we know there's different types of matter and there's different chemicals out there, we need to be able to describe them very specifically using either a chemical formula or a chemical name. So we have to know what we're talking about, basically. So let's begin by describing cations. These are positively charged ions that only have one chemical symbol in the formula. They can come from group 1, 2, or 3. Now, if they're monotonic cations, they're typically going to be metals. There will be some other opportunities for non-metals to have plus charges, but today we're just going to focus on the metals in groups 1, 2, and 3. On your periodic table, you'll find the groups are the columns and the periods are the rows. So group 1 would be the first column. It would start with hydrogen, and next would be lithium, sodium, and you can monitor any reference to see what's next. But group 1 elements have a +1 charge when they form cations. Group 2 elements have a +2 charge when they form ions, and group 3 elements have a +3 charge when they form ions. Now these are metals that we know the charge for, and they're always going to have those charges. Aluminum will always have a +3 charge. Zinc will always form an ion with a +2 charge. Cadmium will always form an ion with a +2 charge. Silver is slightly different. Sometimes it can have a +2 charge, but it's very rare. Most cases it has a +1 charge. But when we're naming these cations, for monotonic cations where we know the charge, we just name the metal and we say, for example, aluminum, ion. Okay, very simple. Now, other metals, which are not listed above in this category, they require some more information because they can have more than one charge. So to make things clear, we use a Roman numeral to describe the charge that's present on these types of ions. For example, copper forms a +1 charge and a +2 charge. So to make it a distinction, we can write copper Roman numeral 1 ion or copper Roman numeral 2 ion. So let's look into how this is done. So on the website, this resource is also very readily accessible. You would find it under the tools, and then you would go under tutorial for chapter 6. You have two options. You can either select formulas or names, and what this allows you to do is go into a quiz format where by selecting formula you enter a number from 1 to 15. Let's start with 1. And it's going to give you the name of an ion. So what you're going to use in this case is you're going to need to insert the chemical formula. So for lithium ion, you need to look in your periodic table and find out its location, and you'll find that lithium is located in the first group. So group 1 cations form a +1 charge. So we would just need to write this chemical symbol, which for lithium is Li, and then it has 1 charge, so we put plus. We don't need to put 1. Press enter, you should get the same thing. If you didn't get the same thing, you did something wrong. So repetition will make things a little bit more familiar to you. So let's try this again. I want you to do this on your own, and then I'm gonna put in an answer, and you should try to get the same thing. So don't be afraid to guess, but you have the periodic table as a reference. Okay, you've had enough time now, so magnesium is located in which group? Okay, group 2, so it should have a +2 charge, right? Now notice for ions, you put the charge after the number. And typically this would be a superscript, but in this form, in the entry format, you can just put it in as a regular size text. Okay, once again, you should have the same thing as me. If not, you've done something wrong. And I'm going to restart, and I'm going to start using the names, and then try to provide the symbol based on that. Okay, so this is very easy. You just need to give the name of the ion. So sodium is represented by the chemical formula Na, and it's located in group 1. We see it has 1 charge, so we name it sodium ion. Okay, so very straightforward. We don't need to do too many of these, but please practice on your own. Okay, so we talked about cations, and if we have something with a plus charge, based on our chemical knowledge and some of the things we covered previously, we know they're negatively charged ions. Those would be the anions. And the way that we name those is by using the root of the nonmetal and "-ide". Now let me show you a list of the name of the root names. These are the list of the root names for the nonmetals. And if you notice, these chemical symbols don't have charges. So these are representing the root names for the elements. For hydrogen, the root name would be hydr. For carbon, the root name would be carb. Nitrogen, nitr. So they're not very easy to say because they don't really fit in our typical language. But in chemistry, this is an opportunity to learn a new language and include these in your vocabulary. So as you can see, most of the word is very similar to the elemental name. And since these are the root names, you will change the end of it. So for negatively charged ions, which are anions, we just put IDE. Okay, so we have the same list, but now these have a chemical symbol with a charge. Hydrogen forms hydride anions. Nitrogen forms nitride anions, and the list goes on. So you want to be able to recognize the name, the chemical symbol, and you should also practice pronouncing these so that when you go into different courses and when you're reading the text, you'll have a mental picture as well as a mental pronunciation. So you have phosphide, oxide, sulfide, selenide, fluoride, chloride, bromide, iodide. And if you'll notice, these all are located in the same group. These are halogens, and the halogens are in group 7. They form -1 charge anions. And this is because they only need to acquire 1 electron to fill their outermost shell. So you can imagine that hydrogen has the same scenario. It's in the 1s group, and that 1s orbital can hold 2 electrons. Hydrogen has 1 electron. When you add another electron, it's going to have the same electron configuration as helium, which has 2 electrons in its outermost shell. So when you see the charge on an anion, it represents the valence shell. So this is a very specific atom in its ionic form. It represents the octet having been satisfied for these particular elements. And as you can see, to fulfill the octet rule, these elements must acquire a negative charge. So like the cations, we can go through a little bit of practice to make these things more familiar to us. So I know I showed you the list very briefly, but since you are smart, you can figure this one out. It has a -2 charge. It's oxygen. Its oxygen forms this type of anion. So if ox is the root word and anions only need the root word and you add IDE, then this must be oxide. Okay, very straightforward. Now, many students just want to know, what do I need to know for the test? Okay, you definitely need to know how to convert the chemical name into a chemical formula. So what's the chemical formula for hydride ion? As mentioned before, the ion is formed by adding electrons, and in this case the additional electron is used to fill the outermost shell. Hydrogen, when it is added by one electron, it acquires the electron configuration of helium, and it only will receive one additional electron, so it only has one negative charge. Okay, so I feel like you have a grasp on not only how to identify the name as well as the chemical formula of these negative ions, but you also will be able to determine what charge each element will acquire as it becomes an anion. So it's very important that you identify what those are. And as you're locating these on the periodic table, you'll find out that group 6 elements form a -2 charge. And which group would this have to belong in to form a -3 charge? Which group needs 3 electrons to form the valence octet? It must be group 5. They already have 5 in the outermost shell. They need 3 more. So these are located in group 5, group 6, and group 7. So those are some ways of sort of teaching yourself and using the organization of the periodic table to learn better. So we were describing monotonic anions, and those are just representing one atom in the chemical formula. But because of the chemistry and the way that atoms can be arranged in space, we can have polyatomic anions where there's more than one chemical symbol in the chemical formula. For example, the anion ammonia has 1 atom of nitrogen and 4 atoms of hydrogen. And because of the charges that's acquired, you form anions. So you have different types of anions, and they're based on the composition, of course. So hydroxide has a -1 charge, carbonate has a -2 charge, phosphate has a -3 charge, nitrate has a -1 charge, sulfate has a -2 charge, and acetate has a -1 charge. So what's the practical use for these polyatomic anions? We'll look into that later. But at this point, you need to be able to name the chemical formula, and also be able to generate a formula from the name. So you need to memorize this list. Okay, so there's other types of polyatomic ions that can be made by adding a hydrogen atom. So if we go back to this list, we can see carbonate has a -2 charge, but if I add hydrogen, I form hydrogen carbonate. Now what's the difference? The charge is different and the chemical composition is different. You have a covalent bond of hydrogen to the additional atoms, carbon and oxygen. And this is the same case for hydrogen sulfate. So here sulfate has a -2 charge. So basically what you can see is that the hydrogen has only, when it does not provide an electron and it's added to a molecule, it brings a positive charge and it changes the charge on the precursor molecule. Not only that, you rename these differently. You call these hydrogen, and then you add the name of the anion, the polyatomic anion. So you also need to memorize this list, and you also need to be able to distinguish hydrogen phosphate from phosphate, and once you can also have two hydrogens added to increase the charge. So in this case you have dihydrogen phosphate. So it's really not much to be said. It's pretty much straightforward, and it just requires memorization. Okay, so why don't we take a 5-minute break and come back to talk about recognizing ionic compounds.